Good news, everyone. What's better than case 2? Not yet. Cases 1 and 2 in one problem. Let's do that. Oh, I'm so sad for you. How does the denominator factor? Yes, pull out an x first. Because there's a GCF. Oh, thank you. Pull out an x first. You're going to have 4 times the quantity, x times the quantity 4x squared plus 4x plus 1. And then 4x squared plus 4x plus 1 is a perfect square that everyone knows and loves. It's 2x plus 1 quantity squared. So the reason this is a combination of cases 1 and 2 is because this factor is linear, multiplicity of 1. This factor is linear, multiplicity of 2. That is your combinations of cases 1 and 2. The multiplicity dictates the number of fractions we need. How many fractions do we need? 3. We need 1 fraction for the factor of x. We need 2 fractions for the factor of 2x plus 1. 1 to the first power, 1 to the second power. All right, what's the numerators going across? A, B, C. Pink. Questions on the setup? All right, the next step is the same regardless of the case you're in. Multiply by the LCD, x, 2x plus 1, quantity squared. Canceled. What do you got on the left? Good. Good. Careful, plus bx times 2x plus 1, because only one of them cancels. And then plus cx. If, that's up to you. If you're going to do it as a system, then you'd have to FOIL out this 2x plus 1 first for A, distribute the A, distribute a bx through, and then this one just hangs around. And then do your system. Or you can plug in numbers in case 2. The thing is, though, notice when you go to eliminate A, B will also eliminate because they have a common factor. Notice when you go to eliminate C, B will also eliminate because they have a common factor. So because of this, you'll have to find A and C first, plug those numbers back in, and then you can find B. So that's if you're going to do the number route. So pick your fave, go to town, give you a minute or two. gonna do it now. 27. I got negative 17. Negative 17. Magic. So this would be 24 halves.
Oh, I did something that I didn't.
Yeah. Yeah. By the 7. Mm-hmm. Yeah. All right, to solve for the a, we put in 0 for x. You get a to be 12. To solve for the c, we put in x to be negative 1/2. We get negative 17. So put your c in. You can use that, yeah. Put your a in. And now pick a number that is not 0 nor negative 1/2, because that would make the b term go away. We can pick 1. So picking 1, I'm going to save some space here. On the left would give us 19. Picking 1 on the right, we'll get 2 times 1 plus 1 squared is 9, so 12 times 9, 108. And then we'll get plus b times 1 times 3, so 3b. And then just minus 17 times 1, which is just minus 17. So again, all these x's become 1s. All your bases belong to us. Solving for b by, you can combine the 108 and the 17 if you want first, or subtract both sides by the 108 and add a 17. And then divide by 3. What do you get for b? Negative 24? Hooray! Okay. So your final answer would be 12 over x plus negative 24 over 2x plus 1 plus negative 17 over 2x plus 1 quantity squared. So as I said before, if it's negative or if it's got fractions, keep it in the numerator. Okay, let me duplicate this real quick, and I'll show you what the system would look like. No, don't erase this. Why'd you erase that? If you want to go the system route, you will get to, because it's a privilege, FOIL out that 2x plus 1 to be 4x squared plus 4x plus 1. You can distribute an x through here if you want it this time. And the cx just tails along. So now if you distribute the a and the b through, oh, I didn't lose my square. We're good. We would get 4ax squared plus 4ax plus a plus 2bx squared plus 2b plus cx. Oh, thank you, 2bx. Oh, I see. Thank you very much. Plus bx plus c. Here's the deal. So now you compare coefficients to coefficients. What's the coefficient of x squared on the left? 0. You're on the left. You want to use this. 0. What's the coefficient of x squared on the right? 4a plus 2b. What's the coefficient of x on the left? This 7. Coefficient of x on the right? Plus c. And the constant on the left? And the constant on the right? A. Well, technically, this is not that bad. You don't have to do a matrix because you already know A is 12. Then you can put that 12 into the first equation to solve for B. Then you can put both of those numbers into a second equation to solve for C.